Alright, this is 6.3 Central Limit Theorem. This is the practical side of things, okay? Now, we already know that to get a z value, x minus mu over sigma. It's always going to be that for all of our distributions. But all of a sudden, our book is giving us this new formula, x bar minus mu divided by sigma over the square root of n. Huh? Where's that coming from? Well, it's actually not coming from anywhere. Here, this is how you find the z-score, but now we're taking the z-score of our sample distribution. All right, let me overemphasize that. This is our sample z-scores. Because it's a sample z-score, we're looking at our averages, so our x bar instead of x, and it's going to be minus our sample mu divided by our sample standard deviation. But wait, don't these look familiar? Don't the sample means and the sample standard deviations remind us of something? Yeah, the central limit theorem tells us that the mean of the samples is equal to mean of the population the samples were pulled from. But the standard deviation of the samples is going to equal the standard deviation of the population it came from divided by the square root of n. So I'm going to take these pieces and just translate them over to what we had. And that's where we have this new information. Now, when you're trying to calculate your z values, everything is the same as it was in 6.1 and in 6.2, except once they have the word sample, circling and overemphasizing that, you're going to have to grab out n from the words in the problem and then just use the new formula, which has a square root of n on the bottom. That's it. Nothing else to go on with 6.3. We'll have something very similar with 6.4 when we're approximating the binomial, but we'll get to that when we get to that. For now, you have to use in 6.3 this formula, reason being samples. As soon as you're doing samples, this is the z formula you're using, which translates into this.